Okay, let's talk about functions a little bit more. Today we are continuing 3.1, but we are focusing more on domain and range. So the domain is all possible input values, or in other words we say, what can x be? If x cannot exist in the function that we have, it is not part of the domain. Then we have the range, and that is all possible output values. We put in x up values and get out y values. So we say, what can y be? So let's look at an example. If we have, what are the domain and range of the function? I can have a function here on the graph, and I have all these dots, 5 little dots here on the left. We can write our x and y points so that we have x and y. X is always first in your ordered pair. So we have -2, 0, -1, 1, 0, 2, 1, 3, and 2, 4. It's not quite drawn to scale, but these are what the points are. Then we can say our domain, what can our x values be? Well, they're written right here. It cannot, however, be any of them in between, because we don't have a line drawn between all of the points. So it is just these points. So our domain is -2, 1, 0, 1, and 2. The graph is not connected, so it is just the points. Then what can our range be? What are the possible y values based on these x values? And our range is 0, 1, 2, 3, and 4. It starts down here at 0, and the highest it goes is 4. Let's look at another one. So I have another function here. This time it is connected, so our domain and range are going to look different. So we say, what are the domain? What is the domain? What can my x values be? And it can be as far negative as -2, and it goes as far positive as 3. So we'd say our domain is -2 through 3, but the way we would write that is -2 is less than or equal to x, which is less than or equal to 3. 2 is the smallest, 3 is the largest. We're talking about x values, so x goes in the middle. Then we look at our range, our y values. The smallest y value I have is 1, and the largest or highest y value I have is 4. So our range goes from 1 to 4. We're talking about y values in the range. So our graph was a solid line. It's connected the points, so it is a range of values. So it can be anything in between here. We can have half for our x, and that works. We get some y. It doesn't have to be just all the whole numbers. Let's look at another one. So if I have a function that looks like this one, it looks like a u. This u is actually called a parabola. It's a fun term for you to know. Hopefully when you see one like that in the future, you'll say, oh yeah, I've seen a parabola before. So we're talking about domain, and it's not quite exact. You could say the domain is -2.5 or -3, all the way up to 2.5 or 3. So our domain is from -2.5 up to +2.5. Just looking at what can my x values be. Then the range, what can my y values be? -2 is the lowest, and 4 is the highest. And it can equal those. We can have points on here that are -2 and 4. So we include the equal sign on our inequalities. that's domain and range. Let's talk about some other terms. So we have an independent variable, which is a variable that represents the inputs of a function. It can be any value in that domain. So inputs are x's, and that is the independent variable. Independent input. If we have independent variables, we can also have dependent variables, and those are variables that represent the output values, or the y values, because they depend on the independent variables. We put in an x, we get some y, and that y changes based on what x is. So outputs depend on inputs. We can say y is a function of x, which means y depends on x. You might also hear that y with respect to x means the same thing. Y is a function of x. So we think which one changes and which one needs the other one to know what it is. Let's look at an example of this. So if we say the function y equals negative 2x plus 8 represents the number of water, the amount of water left in your glass after you take x number of gulps. You have a glass of water, you're taking some sips. What is that going to be? So we're going to find the independent variable and dependent variable. Independent is our input. Dependent is our output. Our independent does not matter what the other one is. Dependent variable does matter what the other one is. So independent variable here is going to be the number of gulps, which is x. Then our dependent variable is the amount of water. The amount of water changes based on how many gulps we have taken. Then we can have domain and range with that. To find the domain and range, we have to make a table of values. So if I make a table here, I have my x, I have my y, and for different values of x, I plug those in to my equation. I started at 0 because I cannot have a negative number of gulps. I can have 0 number of gulps. If I just have the glass and I set it down, I don't take any sips, that's 0 number of gulps. So then I have my amount of water left is 8. There was no units given, you could assume it's ounces. If I take 1 gulp, I have 6. 2, I have 4 left. 3, I have 2 left. And after 4 gulps, I have no water left. So, no water left, we can stop at that point. So then, my independent variable is going to be my domain. What can my x be? 0, 1, 2, 3, and 4. I can't have like 1.5 gulps because it's either 1 or 2. Then my range, listed here, is 8, 6, 4, 2, and 0. You could list it from greatest to least or least to greatest. I just matched it so that my points, they would be ordered pairs in a line here.